All right, good morning, guys, or good afternoon. I'm not sure when you're watching this, but I want to welcome you back, and we are ready for Module 5, Lesson 3. Okay, Module 5, Lesson 3 tells us I can decompose or break apart non-unit fractions, okay, and represent them as a whole number times a unit fraction using tape diagrams. That might sound, again, complicated. We know that Eureka Math uses big language, but don't want anybody to be scared off by that language. We're going to put some times in there or some multiplication in there today with our fractions. Similar to when you started learning multiplication in third grade, when you saw repeated addition became easier with multiplication. So we'll see that used in just a little bit. Before we get started here, let's flip over and let's do just a little bit of practice. I'm going to move this out of my way while I'm sitting on that board. Okay, no, I'm not going to make you do Miss Elizabeth's work there today. Let's do one 2-digit by 2-digit multiplication problem and one long division problem. Let's get warmed up that way. Okay, so let's go with 64 times 58. Okay, I'm going to give you a minute to work that, but you can pause the video, work it completely until you're finished, and then turn it back on to check your answer. I'm going to add that little dinosaur. Oh, forget which mode I'm in. The little dinosaur head there to help you remember some of your steps. Okay, go ahead and work that problem out. Push pause on the video. Okay, hopefully by now you're finished with the 2-digit by 2-digit multiplication problem, and we're going to work through that. So let's do that right now. We've got 8 times 4 is 32, so we put the 2 and we carry the 3. 8 times 6 is 48, 49, 50, 51. Okay, we're done with the 8. The dinosaur lays its egg there, and we're ready to move on to the 5. 5 times 4 is 20. Put the 0, carry the 2. 5 times 6 is 30, plus 2 more is 32. So your top row would be 512, your bottom row 3,200, and then we would add all of those together and get 3,712 as our final answer. Okay? All right, let's move on to division. We're going to have 589 divided by, let's go with 7. Okay, so again, pause the video, work the problem out, go ahead and check it with multiplication. That's great practice, and see if you get the correct answer that way. But also turn it back on to see if you've gotten it correct through checking it with me. Okay, go ahead and pause the video. And turn the video back on, or I guess you've done that. Push play, and let's work this out. How many 7s can I get out of 5? 0. How many 7s can I get out of 58? Well, let's think of our 7s. Let's think of our multiplication facts. 7 times 8 is 56. That's as close as I can get. I want to get as close as I can without going over or getting too big. So I'm going to subtract that, get 2, and then bring down the next digit. How many 7s can I get out of 29? Think of your 7s. 7 times 4 is 28, so that's pretty close. We subtract that and have 1 left over and nothing to bring down. So that is left over, and that becomes our remainder. When we check our work, we got 84 times 7. These two numbers right here. Multiply them together. 78. And then we've got to add that remainder in there. So 589, 589. When we multiply that and add in our remainder, we should get our dividend right there. There you go. All right, hopefully that's gotten your mind, warmed up for some math today. Let's erase this and switch back to where we were. Okay, now a lot of these beginning slides are practice, and it's great practice for you to go through. If I went through every one of those practice slides, this would make our video extremely long, so I'm going to jump into our lesson right now, right here, okay? All right, so we're going to pull in what we've been doing the last couple of lessons, the last couple of days. That's going to help us with today. We are still using tape diagrams, but I hope that you're getting more and more comfortable with those, because the more we use them, the more we see how simple they are with fractions, the less scary and unfamiliar they'll seem. Okay, they'll just become something very easy to use. It's just one more tool in your toolbox. So here we have a tape diagram, and we've got 3 questions to try and answer. Okay, because all 3 of these questions are going to help us towards what we're doing today. These whole first few lessons are helping us get really familiar and comfortable with fractions and what they mean and what they can do. Okay, so I'm going to choose a color here that's, green is good because there's no green here. All right, so we have a tape diagram, and the first question says, what fraction is represented by the shaded part? So we want our fraction to begin with. That's going to help us start everything. So we have a tape diagram that is divided into 4 equal parts. Okay, so that is going to be, we know that 4 equal parts. All right, what did I just do? Let me undo that. All right, sometimes I've got to turn this off and turn it back on for some reason. Okie doke. Maybe it'll work now. All right, we're going to just show that this is equal to 1. This is 1 whole. So if that is 1 whole, we've got 4 equal parts as our denominator. 4 parts makes up the 1 whole. How many are shaded? 3. So our fraction that we're going to be working with is 3/4. What fraction is represented by the shaded part? 3/4. Okay, so we've answered that question. The second question, say it as a sum. Okay, we know that has to do with adding, of unit fractions. We know unit fractions always have a 1 as the numerator. Okay, so how am I going to show this as a sum of unit fractions? Now that's what we've done over the last couple of days. So I'm going to take 3/4 and I'm going to show it as a sum of unit fractions. Well, I know my unit fractions will all have a 1 on top, and they're going to have a 4 as a denominator. Okay, so I'm going to add them up to get 3/4. So that would be 1/4 right there, plus 1/4 right there, plus 1/4 right there. Okay, and that's all there is to that second question. This is showing 3/4 as a sum of unit fractions. Okay, we'll move on to the last question, and that's really kind of the next step today, this last question. How could we show this right here, as multiplication? Now, I want you to think way on back to 3rd grade. And when you were in 3rd grade, you had worked with math in lots of ways, but at some point your teacher started talking to you about repeated addition, where you had the same number you were adding over and over and over and over and over again, and they showed you an easier way to do that, a more efficient way to do that was to not use addition anymore, but to use multiplication. We've answered that question. We've talked about that lots in 4th grade too. Okay, so instead of adding 1/4, plus 1/4 plus 1/4 over and over and over again. We could shorten it and make things more efficient by going to multiplication. So, I'm gonna, oh, it doesn't let me, does it? Okay. I want to make sure it's a color you can really see. So if I'm going to change this to multiplication, I'm going to have 3/4 is equal to, how many times do we see 1/4 there? 1, 2, 3. So we've got 3 times 1/4, or 1/4 3 times. So this is the same as this. This is the sum of unit fractions. This is the addition version in unit fractions, and this becomes the multiplication. But these are the same, these are equal to the same thing. Okay? So very simply, we're not repeatedly adding anymore, we're multiplying it that many times. Okay? But we're going to get the same answer. Okay. So let's move on and practice this a little bit. All right, so here we have a whole nother tape diagram, and we're going to answer these 3 questions about it as well. What fraction is represented by the shaded part? Say it as a sum of unit fractions. How could we show this as multiplication? Same 3 steps, same 3 questions. Okay, so once again, this right here is, if it doesn't show that this is one whole, we're going to assume, we're just going to know that this is one whole. Okay, so how many pieces are in the entire one whole? 1, 2, 3, 4, 5, 6, 7, 8. So we know 8 is our denominator because it takes 8 pieces to make the one whole. Now, how many are shaded? 1, 2, 3, 4, 5, 6, and 7. Okay. So the fraction we're working with is 7/8, and this tape diagram is showing 7/8. Okay. So if we want to show it as a sum of unit fractions, we're going to have 7/8 is equal to, now we're going to add up the unit fractions to get to 7/8. Our unit fraction we're going to work with is 1/8 because these are eighths, and our unit fraction has to have a 1 as the numerator. So we want to make sure we've got the right number of these, so we're going to write them, but we're also going to count them when we're done, make sure we have 7. All right, 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. 1, 2, 3, 4, 5, 6 plus 1/8. 1, 2, 3, 4, 5, 6, and 7. Whew, arm's a little tired. Okay. And usually, even though adding unit fractions is a very simple fraction problem, it's long. Okay, and so we want to find a more efficient way to do this, and we're going to do that with multiplication. So what is this going to look like as multiplication? It's going to be 7/8 is equal to, how many times did I write 1/8? 1, 2, 3, 4, 5, 6, and 7. 7 times 1/8, or we had 1/8 7 times. So you see how much shorter that math problem looks? It's quicker to write. It's what we call more efficient. Okay? All right. Now we will get much more into multiplication with fractions down the road, and you'll really get into them next year in 5th grade. But we will do a little bit more with them down the road. This is just kind of an introduction to how this can equal this. All right, let's keep going. You guys are doing awesome. Awesome, awesome. Now, you look at that tape diagram, you may immediately think, it's nothing shaded. I wonder what's up there. If nothing is shaded, we're just going to assume that we've got all of it, okay? And so we're going to write a fraction that this tape diagram is showing. And we're going to assume that we have all of it because nothing in particular is shaded. So don't let that throw you off. All right, now you also can notice, if you were here with me, I'd be asking you a lot of questions about hey, what do you notice about this tape diagram that's a little different than the ones we've just been working with? This tape diagram, and hopefully what you've noticed is that this tape diagram creates a number that's larger than 1, because we see right here is where 1 hole is, and 1 hole stops right there, but the diagram continues on. The diagram's a little larger, so this fraction is larger than 1, which is also a clue that it is an improper fraction. The numerator is going to be larger than the denominator. Okay? So let's create our fraction here. We've got 1, 2, 3. Let's mark them. 1, 2, 3, 4, 5, 6, 7, 8 pieces in the 1 hole. So I have to just look at that to get my denominator. There are not 10 pieces in the denominator in the 1 hole. There's only 8. So 8 is our denominator. That's how we figure out our fraction, our denominator. We have to stop at what is the 1 hole. Now, there are 2 extra pieces here. So if we have all of it, how many do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 eighths. Okay? We have 10 eighths. We're assuming that we have it all. Okay? There are 8 pieces in the 1 hole, so that's our denominator, and we have 10 of them. We have those 2 extra pieces makes 10. So there we go. That is what our tape diagram is showing. All right. So we want to say this as an addition sentence using our unit fractions. So 10 eighths is equal to 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. 1, 2, 3, 4, 5, 6. Plus 1/8 plus 1/8 plus 1/8 plus 1/8. Whew. Rest that arm. Those are long. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I want to double check. When those get that long, we want to double check we've drawn or written the right number of fractions. So there is our addition sentence using unit fractions. Okay, so now we want to make this into a multiplication sentence. So we will do that right here. 10 eighths is equal to, how many times did we write this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, whoops, got the elbow in the way. 10 times 1/8. We've got 1/8 10 times. Okay. All right. So hopefully after saying it multiple times now, many times now, we're kind of getting the hang of how this works. All right. So, you know how Eureka Math works a lot of times. They will give us a problem one way, and then they'll switch it up and show us things from a different angle a little bit. So now this is what we've just written. We had that on our board just a minute ago. How many eighths make a whole? Put parentheses around them. Okay, well, how many eighths make a whole? If we look at the cheese pizza right here, how many, these are all eighths, because this pizza is cut into 8 pieces. I'm not sure if you can see me. Here's the cheese pizza. Okay, these are cut, this pizza is cut into 8 pieces. So how many pieces do I need to make the whole thing? I need all 8 of them, don't I? Because if even one is gone, I don't have a whole pizza. So I need all 8 pieces. When it's cut into 8 pieces, I have to have all 8 pieces for me to have one whole. So it says to put parentheses around them. Let me make sure I've got 8. 1, 2, 3, 4, 5, 6, 7, and 8. That's what they mean by putting parentheses, because that helps me see that that group of 1/8 is equal to 1 whole. 10/8 can also be written to show 1 whole and 2 more eighths. See, I've got 1 whole right there, and then I've got 2 more eighths. So what's in parentheses is equal to 1 plus 2/8. And a lot of times when you see a whole number like that with that fraction, it will actually be written 1 2/8. It's almost like there's a little hidden plus sign right there. And you also hear the word and, 1 2/8. So it's like they're joined together. Okay? And this is what we call a mixed number. So here we had the improper fraction, here we have the mixed number. And as we go along with our fraction lessons, we're going to have a lot of practice changing an improper fraction into a mixed number, and even going from a mixed number to an improper fraction. And you'll see we do that for lots of different reasons as we go. So, all right, one more way we're going to work with this today. Draw a tape diagram to show 5/3. So this time we're not being given the tape diagram first. We're being asked to draw the tape diagram. And yeah, I do want you to practice this. Draw a tape diagram to show 5/3. 5/3. Okay? If it helps you, write that as in number form first. 5/3. Okay? Now, this tells you that the 1 whole has to have 3 parts. So 1 whole has to have 3 equal parts, and that makes up 1. Okay. But this number, the numerator, tells me how many pieces I have, how many thirds that I have. I don't just have 3 of them. And, you know, if it bothers you that they're not shaded, you can shade them. You don't have to. Okay, so I have 3/3, but actually I really need more. I've got 5/3, so I need 2 more. Okay, but this is my 1 whole, and then I have a little extra. So there is our tape diagram to show 5/3. Now, how can we show 5/3 as a multiplication sentence? Okay, so they're jumping right to the multiplication. Well, we've got 1/3, 1/3, 1/3, 1/3, and 1/3, correct? Okay, if we needed to write that, we could. If it helps you to see this. But you might automatically recognize, okay, that's 1/3 5 times. So 5/3 is equal to 1, 2, 3, 4, 5. 5 times 1/3. Okay. Now this pink question here is saying, is there another way? And there is. We've talked a lot this year that there is more than one way to solve a math problem. And so there is another way to look at this, and let me show you what they mean. Let me erase this for a second because it's a little bit in the way of what I want you to see. There we go. I will move it out of the way. Let's see. Let's put that over here on this side. We've got 5. Well, need the pen. Okay. 5/3 is equal to 5 times 1/3. Okay, we'll keep that there. This is a true math sentence, a true multiplication sentence. This works, but is there another way? Yes. Okay, you see how these 3/3 are kind of all together to make 1 whole? Okay, and that these 2/3 are the extras, if you want to call it that. Okay, now I didn't change the amount of these numbers by putting parentheses. The parentheses just grouped them for me. Now we know that we can group our numbers in lots of different ways, but this is just one way. So I might want to put these 3/3 together and say, let me change the colors. Okay, 5/3 is equal to, okay, here's 3/3 right here. So 3 times 1/3. I just changed this from, possibly adding those thirds to multiplying them. But I can't forget this out here. So plus, let's do this group. We've got 2 times 1/3. Okay? Now this looks super fancy, doesn't it? We've got 5/3 equals 3 times 1/3, which is right here, plus 2 times 1/3. This is the same as this. It's just a different form. Okay, but they equal the same thing. It's just one other way to get to 5/3 through multiplication. Okay, but it's good for you to see that that can happen in more than one way. All right, let's jump here. Now, this makes our video a little bit longer, but realize we're now to our problem set. Okay. And we're going to work a lot of these together today. So if you would get right now your workbook, okay, for Module 5, and turn to Lesson 3 problem set, which should be on page 11. This is an older workbook, and every now and then they print new ones and the page numbers don't line up exactly. But go find your workbook, get that in front of you, and turn to the problem set for Lesson 3. And it should be on page 11. Okay. All right. Let's erase that. And this is problem set for Lesson 3 right here. And we're going to work these together. If you would like to try them on your own and you want to stop the video, read the directions for yourself, or just listen to the directions and then stop the video, you can do that and then turn it back on and check your answers. That's fine too. But here we go. We're going to work through these. So the first one is done for us, but let's look at what they're asking us to do. We're going to decompose each fraction modeled by a tape diagram. So they've already got the tape diagram. We're going to decompose them as a sum of unit fractions. So we're going to create an addition sentence with unit fractions. But then we're also going to write the equivalent multiplication sentence. So we're going to write the addition sentence with unit fractions and the multiplication sentence to go with it. Okay, pretty simple. So at the beginning here at least, the tape diagram is already done for us. So we're going to start with letter B. This is what one whole is, and we see that one whole is 1, 2, 3, 4, 5 pieces long. How many are shaded? Just 2. So always a good idea to get your fraction written down at first so you know what you're working with. Now we're going to make it into an addition sentence with unit fractions. 2/5 is equal to. All right, we're going to be adding unit fractions. Unit fraction, it has to have a 5 on the bottom to go with this, and it has to have a 1 on top to be a unit fraction. Okay, 1/5 plus 1/5. All right, pretty simple there. That's it for the addition sentence. But now we want to create the equivalent multiplication sentence. So 2/5 is equal to, well, ask yourself, how many 1/5 are there? This is like repeated addition changing to multiplication. How many 1/5 are there right there? Well, there's 2. And we're multiplying by 1/5. So I have 1/5 2 times. You can hear that. 1/5 2 times. Okay? So there we go. That is it for problem B. All right. I'm going to erase that. And I'm going to turn, well, you don't have to turn a page, but I do. I have to change my slide. All right, we're moving on to letter C. Here we go. And if at any time you need to pause the video to catch up or to work the problem and then turn it back on, you can do that. All right, so we see this is what makes up one whole. 1, 2, 3, 4, 5, 6 pieces make up the one whole. How many are shaded? 1, 2, 3, 4, 5 of them. So we are working with 5/6. Okay. All right, so out here we will have 5/6 is equal to, okay, we're going to be adding unit fractions, all 5 of these. One, 2, 3, 4, 5. There's our addition sentence. 5/6 is equal to 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. Repeated addition, not very difficult, but long. Okay, so here we change it to the multiplication sentence. 5/6 is equal to 1, 2, 3, 4, 5. We got 5 times 1/6. Okay. I really, really, really wish I could say, does anyone have a question, or what questions do you have for me? So if you have some big questions and you need your folks at home to send them to me through Remind, and I believe there's a way to do it in Google Classroom on the, you can do that if there's something you don't understand. Hopefully this is making sense to you. I sure hope it is. Okay. All right, so once again, here's our one whole all the way to here. 1, 2, 3, 4, 5, 6, 7, 8. So our fraction is going to have 8 total pieces. I'm actually going to move that. Uh-oh, look at what I just did. Yep, I'm known for doing that, aren't I? Erasing everything. All right, that's okay. It gave us some more space that way too. 1, 2, 3, 4, 5, 6, 7, 8. Okie doke. Let's just do this. I don't know why that's acting funny. Okay, this is 8s. How many are shaded? Well, it's 8s, and 2 of them are not shaded, so I know 6 are shaded. Okay, so we're going to add those with unit fractions. 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. 1, 2, 3, 4, 5 plus 1/8. That gives us 6. Now we're going to change that to multiplication. 6/8 is equal to 1, 2, 3, 4, 5, 6 times 1/8. We have 1/8 6 times. Okey-doke. All right. One final one of this type. Now, this one is a little different. We can automatically see, this is an improper fraction that's going to be larger than 1. So how many pieces are in the one whole? That's key. That is a very important question there. There are 1, 2, 3 pieces in the whole. So our denominator is 3. But how many of those pieces do we have? 1, 2, 3, and 4. So we have 4/3. Well, 4/3 is going to be equal to 1/3 plus 1/3 plus 1/3 plus 1/3, so that we have 4 of them. And if we're going to change that to repeated addition, if we're going to go from repeated addition to multiplication, we're going to have 4/3 is equal to 1, 2, 3, 4 times 1/3. We have 1/3 4 times. Okay, and so that is how you do that type of question. Now, your problem set, though, does not stop there. It moves on to this type of question, where all they give you this time is a fraction. And they ask you to draw a tape diagram and record the given fractions decomposition into unit fractions as a multiplication sentence. All right, so here we go, and this is what these are going to look like. We're going to have to start off by drawing the tape diagram this time. We have 4/5, so we're going to draw a tape diagram that is cut into 5 pieces. And that is the one hole. Make sure you label it up there. And 4 of those pieces are shaded in. This is our quick math shading. Okay. So we have 4/5 is equal to 1/5 plus 1/5 plus 1/5 plus 1/5. We have 4/5. You could do this underneath it. You could also do it beside it. I'm just doing it beside it because of my space. 4/5 is equal to 1, 2, 3, 4 times 1/5 because I have 1/5 4 times. All right, and so those are the 3 parts that you need for these types of problems. The tape diagram, labeled and shaded. We need the addition sentence with the unit fractions, and then we need our multiplication sentence that matches that. Okie doke. So let's move on to B. B says 5/8. So our tape diagram will be cut into 8ths. This is one hole. 8 pieces make one hole, but I only have 5 of them shaded. 2, 3, 4, and 5. Okay, so I have 5/8 is equal to 1/8 plus 1/8. You know, make sure that your denominators all match. It's easy to get those mixed up sometimes, so make sure they do. 1/8 plus 1/8 plus 1 more 8. That should be 5. 1, 2, 3, 4, 5. Okay. And then for multiplication, we have 5/8 equals 1, 2, 3, 4, 5. 5 times 1/8. We have 1/8 5 times. Okay, letter C, 7/9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so we have 9 pieces make up the one whole. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then we have 7 of them shaded. Okey-doke. So we have 7/9 is equal to 1/9 plus 1/9 plus 1/9 plus 1/9 plus 1/9 plus 1/9. 1, 2, 3, 4, 5, 6, and one more would make 7. Whew. You should have some good, strong muscles after this for all this writing, okay? And then we're going to write that as a multiplication sentence. 7/9 equals 7 times 1/9. You have 1/9 7 times. Now, moving on to these last 2, you're going to see them be slightly different, especially the tape diagram, because they are improper fractions. So, look at that fraction carefully. I see that my denominator is 4. Don't get tricked by that 7. 4 is your denominator, so there are 4 pieces in the one whole. So I'm going to draw the one whole as 4 pieces. But I have 7 of them. So when I go to shade, I'm going to shade all 4 of these. But I'm going to add the extra 3 pieces that I have that are also 4ths. Okay. And so 7/4 is equal to 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4. 1, 2, 3, 4, 5, 6, 7 of them. So that also means that I have 7/4 is equal to 1, 2, 3, 4, 5, 6, 7. 7 times 1/4. I have 1/4 7 times. Okay, so last one here. We've got our tape diagram. And if you look closely, you see that the denominator tells me I need to cut the one whole into 6 pieces. So one whole is 6 pieces, but there are 7 of them. So I'm going to go to shade. 1, 2, 3, 4, 5, 6, but I have to have 7. I can't count to 7 yet. I've got to add that extra 6th right there. I've got to add that extra one so that I have 7/6. Okay, so 7/6 is equal to 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6 plus 1/6. 1, 2, 3, 4, 5, 6, and 7. Okay. Now, changing that to multiplication, 7/6 is equal to 1, 2, 3, 4, 5, 6, 7 times 1/6. So once again, guys, this is just like repeated addition back when you were in 3rd grade and you were just learning your basic multiplication facts and how multiplication worked. Multiplication is just repeated addition. It's just a faster way to do it. Same here. Instead of writing 1/6 so many times, we would eventually want to get to where we're using multiplication with our fractions because it's just more efficient. Okay? All right, so I hope this has helped you kind of get a beginning understanding of multiplying with fractions using those tape diagrams. Let that tape diagram be something that's helpful to you. It's a tool we can use and not something that's scary or bothers us in any way. Now, you are not finished here, okay? Once you have done all of your problem set, you need to go back to Google Classroom. You need to go in and find the exit ticket for Lesson 3 of Module 5. You need to do the exit ticket, and then you need to submit it. And then you also need to make sure it's turned in as done, okay? So make sure you've done that because that is how I know you've completed the lesson. Because it shows up on my end because I can go in on my teacher page and see that you've completed the exit ticket. So make sure you get that done. But do this, of course, first so that you understand what you're doing on the exit ticket. Okay? So do the best you can and hope to see you soon. Bye, guys.